let's revisit our weighted average, okay? So instead of just thinking about averaging the local pixels, let's think of this as a set of weights, okay? And what we're going to do is we're going to weight all of these pixels by some set of weights, and we're going to combine them using those weights to come up with the new value. Now, when we were just doing the moving box, our weights were just, let's say if it was 5 long, they would be 1/5, 1/5, 1/5, 1/5, 1/5, 5 of them, right? So our weights were uniformly distributed, okay? But wait a minute. Does that make sense? Remember our assumption that nearby pixels are related to my value? And there's another related assumption to that. The more nearby you are, the more related you are. So that means that pixels that are closer to me should contribute more to the average. So let's change our moving average so that that's true, okay? Before, if you remember, we had these uniform weights, 1, 1, 1, 1, 1, all the way across divided by 5. What if we wanted to use some non-uniform weights? So here's a set. 1, 4, 6, 4, 1 divided by 16. And what I'm going to do is I'm going to change those weights from being uniform to being non-uniform. And I want you to watch what happens to this bottom picture, right? So this is the uniform weight, and that's the non-uniform, center weighted, right? Uniform, non-uniform. And you'll notice that the non-uniform is a smoother rendition. In fact, take a look here. This area right there, we get a smoother range of what's going on. And the non-uniform weights corresponds to this assumption that the more nearby a pixel is, the more weight it should have.